in the best way possible always. I love that. So my name is Tomás Nabrava. I work for Code, and I am a free software advocate, and I worked for free software for 20 years. I joined the KD on 2004, really, really long time ago. I am 40. Currently, I'm working with Codevis, which is a framework for large-scale software analysis. I'm also a developer for Bloomberg, for KD, and for our Linux, because apparently I have no better things to do than to code. And I have no pointers, so I will always come here. When the software architecture is wrong, there is no way for you to fix that in the future, or when there is, it is too costly. It will spend thousands and millions and billions of dollars working trying to get something that is horrible to something that will be maintainable in the future. The result will always be subpar. As soon as you are starting a company, if you do not pay attention to software design, your company will not scale. And that's an important thing to pay attention to, because open source software, closed source software, it does not matter. If you started your software without taking care of the architecture, you will not get far. Or it will, but it will cost a lot. Also, if anyone wants to interrupt me, please do. I have no problem being interrupted constantly. And I know that sometimes my English is really fast, so just poke me and I will repeat slower. So, what the hell is Codevis? It's a lot of things at the same time. It is based on the book Large Scale C++ from John Lakos. It is also a software that will be applied to way more languages than C++. Currently we support more, but we plan to have most of the good languages, of the languages that are being currently used in the world inside of our toolkit. We have specific code already for Python, PHP, Java, and C#. Not fully working, that's the reason that we are not integrating the yet. And it already works. It's already have features issues in LLVM, in the Qt Foundation, and the KD repositories. Each one of those things here have more than 2 million lines of code. At least LLVM has at least 5 million. Qt has around that. KD has 85 libraries and 400 software. And we were able to ingest all of that and fix issues. And it's also being used by Bloomberg. Bloomberg is sponsoring this project, so I need to say, be honest with you, that a large company is sponsoring my work, but it's also being useful for them. This is Codevis, and this here is also Codevis. This is Codevis analyzing Codevis itself, because I need to use what I produce to make sure that the thing that I'm doing will help people. And what you see here is each compartmentalized library from different aspects of Codevis and disposition numbers. Things that are in the bottom do not depend on anything. Things that are directly above it depends on the things that are in the bottom and subsequently. So this thing here can depend on everything. This thing here depends on nothing. So as soon as you look at this, you already know which is the most important thing, the foundation. And then you know how your libraries interact. But you see, the code that I just told you that I did, it's also a mess. It is a lot of information here, and just by looking at this, you have no idea, you have no clue on what to do. It's the problem that we were discussing about. It is just too much data to analyze for a single human person. But let's advance. So we have analyzers. We make sure that we are ingesting large-scale code bases from day one. From day one, we were ingesting LLVM, Qt, and the KD libraries, and those, in a sum, is more than 10 million lines of code. So we always try to make sure that our software was ready for production. Not good, not perfect, but ready to be used in real software. The visualization framework in UI is decoupled from the algorithms that the analyzers So you can run the analyzers anywhere, and then you visualize the results. And a plugin system, because I might be a genius, I am not, but I might be a genius, and I might think that I know better than you everything that you need to use. And then I might forget things. There is maybe something in your projects, in your company, that you want to visualize in a different way that I did not take care of. So we have a plugin system to fix those things. We support, on the language level, Clang, which will ingest C, C++, and we also support Flame, which is the Fortran compiler of LLVM that will ingest Fortran. But why am I on 2024 looking for Fortran code? Isn't Fortran dead? No. Fortran is still used inside of supercomputers, and no company will ingest, no large-scale company, no company that actually has data centers that run supercomputers will use my software if my software does not use Fortran. So Fortran is also there. And Fortran can interact with C and C++. As soon as you parse your project, you will see those interactions. Everything that we did on Codevis, we found errors in Qt, we found errors in LLVM. Every time that we found an error, we fixed that error in the library, and we sent all of the contributions back. So we are helping upstream, because this is extremely important. Open source can die if there is just users and never contributors. So for you people here, seeing open source for the first day or using open source on a daily basis, help open source. Why CodeThink might be useful? I have no idea. I am a researcher. I am trying to understand why Codevis might be useful for companies. But we found security issues just by analyzing graphical interactions within models. The XZ attempt Linux hack this week could easily be spotted by Codevis because it was trying to use something that was not on the original file. So if you download it, try to compile, analyze the results with Codevis, you would see a cyclic dependency there that should not be there. So this could be useful for security audits. It could be useful for re-engineering automation, applying AI on engineering and then changing codes, regenerating the graph and seeing if things should be like that. Developer onboarding process, which is something that we already discussed, and visual templates for code and technical documents. What else? We have CI integration. We have 3 CLI applications that can run on your CI or in a distributed system that will generate the information that you need, and then you can deploy the results in database on AI to fit a large dataset model, for instance. If you do not have a CI and you just want to use your desktop application, also useful, you just click in the Generate project. That will bring you this table here, that you fill the information. That will then generate things. And it's fast on your computer because it will use as many cores as possible, as many cores as you have. It can also be used distributed. It will use a local database, so you are not stuck on a server. You can distribute a database, or you can use that on a server. And then that we will be using for visualization and data transformation. And this is the easiest version of the previous graph. This is easier to understand to what I showed before, but it's actually the same thing. Because here I did not explode, I did not show the entire catalog in once. So ignore the names that I'm using for libraries. I am obliged by contract to use those names. True. But it's quite easy to see here that I have a problem. I have a problem because one of my lines is pointing up. Because one of my lines is pointing up, that means that I have a connection from here to project to loader to something. I have no idea what this is. And then this is a cyclic dependency. This is hard to solve. This is hard to fix. And this is an architectural issue on my application that I added there on purpose to verify that my thing was correct, generates the correct graph. as soon as you find this kind of thing, you can say, this is wrong, we need to stop what we are doing, we need to fix this before the software gets too complex. But we have no idea where it is, because this is folders. So we need to expand the folders to see the files, and then you see file to file, which is the file that is creating the dependency. And then you expand the file, and you see the exact methods or exact functions that are generating the dependency. And then you split. Then it's easy. The problem is to find those things. Here we have everything from every single library that your software depends, independent of computer language. So if you compile something in C that uses C++, that uses Fortran, everything, every library will be here with every single thing that the library has. So you're not just analyzing your code, you're analyzing the entire data set. The main view is drag-and-droppable. It's dynamic. One thing that you also said on your talk, that it's hard to have dynamic graphs, dynamic capabilities on this, because tools, they currently work by generating one static graph, and then you need to look at that and infer all of the information that you have. I hated that. I hated GraphViz because of that. Anyone here already worked with GVPR? No? You are lucky. GVPR is an aberration created by GraphViz in the 70s and 80s, which is a command line tool to filter graphs. It's a complete programming language to filter graphs, which is undocumented, horrible to use, full of bugs, and the only thing that companies had until, I don't know, 5 years to filter large data sets. So now we have a dynamic view that can load, unload multiple tabs, split views. You can create, you can remove, you can analyze, and you can add documentation directly on this to showcase to your colleagues. Navigation, expanding, this kind of. We have also an information box. As soon as you move your mouse, we can add more information dynamically to that box. This is also plugin based. So you see that I'm not actually producing a lot of code here, because the main idea is, as soon as I have the data, I need to analyze it. And analyzing is one of the most complex processes that there is. I can also search, because as soon as I have 1 million nodes here, it's impossible to find just my document. So I type what I need, and I quickly jump. And the possibilities. We found an architecture issue, we found a cycle, I found something, but I have no idea what. We relay those through plugins, because my software will never be able to implement everything that your software might need. So the plugin system can add new things on the UI and can add new things on the canvas. The canvas is the drawing part of the graph. It can also look directly into the database. And it's done on Python or C++, because Python is useful if you want to distribute, and C++ is useful if you want to use internal on your company. You do not need to open the source, and you need to make it fast, because Python is really good for prototyping, but as soon as you need the speed, as soon as you are going on a multi-million graph, Python will not go. And it's simple and direct. We ship with example plugins. We have a plugin that will look for code coverage, that will analyze your Git repository and display on the view how much of that file, how much of that folder is covered by unit tests. So as soon as you drop on the view, you see 80%, 90% directly. It also has a cyclic detection, so I actually have an example of cyclic detection, so yeah. And we have a Lagrangian rules. Lagrangian rules is based on the large scale C++ book. I don't think that anyone here cares about that, but some companies do, so we roll that. This is the cyclic detection plugin. We drop something on the view, right click, detect cycles. It will look for your large scale stuff, and then if you highlight the cycles, click on the cycle, you see here what class, what file is having the cycle, so it's easy for you to go there, fix manually. We do not solve the cycles for you yet, but we try to. And then you need to fix and regenerate your graph to make sure that the cyclic relationship is good. More cycles, cycles. I just set everything here, but if you want to take a look, because my English is not perfect. So the cyclic analyzer just analyzes visually the elements loaded, important, loaded, not the entire data set. Because if it is the entire data set, it might take too long. And sometimes you know more or less where the cyclic is, but you are not sure. And if you find the cycles, you click, you analyze, and you make your software more maintainable so that people in the future will not try to kill it. And this is again base plugins in study. So we are studying right now on creating an AI architecture analyzer. It will load your code and try to guess if your architecture is good or not, and maybe try to tell you how you should focus that. Your talk also had something related to that. I mean, our talks were really similar, but focused on completely different things. That's impressive. Also, code metrics. Different styles of code metrics from different researchers. We have a knowledge island that we've also talked about, and I think that I have the same topic. And automatic library splitting based on code levelization. This is nice. So take a look here on the first. Here. I have some libraries that are really small. Those are okay. I mean, I have 5, but I have libraries that are really, really big. I probably could find here in this a cluster of elements that are not being used by anything else. So maybe I can cut this on a line, and then I can separate those things into different libraries. And just by visualizing, it's easy to spot on where those are. We actually have this plugin working already, which is really cool. We implemented it last week. That's the reason that it's not in this talk. But that you select, we generate text file that you'll take a look, and then you will move your files into a different library. I mean, we tell you what to do. We don't do it for you. And go back. AI-based hotspot visualization. You also talking about that, about hotspots and about AI. But basically, without writing the codes, what is most likely to block your program, and what is the biggest possibility to fix? We do not have that. This is just an idea, but it's a doable idea, because we can infer by using perf data, running the code, analyzing, and then showcasing exactly where your program will get stuck or trying to help you fix. And if you want more plugins, you can implement yourself. I can help, because this is completely open source. This is completely free. I do not want to know that your company is using it. I want people to use and tell me, Thomas, you are a horrible developer. Please fix your bugs, because this helps me. But a few corporations already are using, and they already have tools for that. But the tools suck. The tools are usually static code analyzers for package managers, CMake, based on Ninja that generates graph of the building system, or software installation packages like APT and Chocolate that will look for the graph of the installation of things. But those things, they just care about the software, not the source files. They care about the compilation step. And that I don't really care, because a compilation unit has nothing to do with the maintainability of the software. And I want a software that I work for 20 years, and like I have here. I want a software that I worked for 20 years to still be useful in 20 years. I do not want people to throw away my code because it's unmaintainable. So why did I create that? Because I got a page. Because it's easy to develop locally, refresh the UI and see the changes. I do not need to wait for instance, a GitHub or a Grafana or anything else to run on top of it. and Grafana and GitHub, there is a lot of setup involved. And this is basically zero setup. You point the software to your source, you wait, and then you have the results. It's easy to integrate plugins because no software will do everything that we want. So we need to make a way for people to integrate the things that they want. And it's easy to integrate visualizations for the same reason. Success stories, yes, Bloomberg, it's using this already. Yes, KD, which is the biggest open source community. We have more than 2,400 people. It's also using this on some software. What else? For developers, this is open source and permissive. You don't need to pay, you don't need to tell me, I don't care. Merge requests, I accept, and I will love you forever if you send merge requests. And plugins can be used for closed source organizations. They don't need to tell me, they don't need to push upstream. We are corporation friendly. And do I still have time? I don't know how much time do I have. Maybe. So to onboard people, because the software works on visualization, you can create a visualization for your new software, for your plugin, for your architecture. You can document that, and that can generate, because we also add that, you can generate source code from the visualization. So it can ingest code, and it can also spit code. So it's easy to get something small, allow a user to take a look and see, understand the connections, and then work on top of that before just showing a lot of code for him and deal with it. This is a 1 million line of project. You need to deliver something by 2 weeks. That does not work. Architectural visualization is also good, and dynamic documentation. This is really, really nice, because documentation is important for the viewer, and it will also be used when you are generating code, and it can also be ingested when we are reading the code. And IPC from text editors. This is really nice. So I implemented on Codevis dbus. People here know what dbus is. It's a way for two applications to communicate with each other. So if I have Visual Studio Code or CLion, as soon as I open CLion with a plugin, a tiny plugin for Codevis, they can send a message to Codevis. Load this file that I just opened, so I can navigate on my editor, on my preferred VI or Emacs. As soon as I navigate, Codevis will show exactly where I am, on the file that I am, or on the class that I am, which is also really cool, and it helps. It's not something that will save your life. It's a helper, and it's a tool for you to gain knowledge on a source of code source. Documentation plugin. And more that's also a bonus. You can generate source code from C++, Python, Fortran, based on Python templates. So if your company hates the templates that I use for mine, change it.